Hi there, in this video we will learn about the present value of certain situations where there is perpetuity or where the benefits are increasing over time or decreasing over time. So let's start with the first possibility, and this possibility deals with the perpetuity. What is a perpetuity? It's basically an annuity that continues indefinitely. It means that we will have to use the annuity factor formula and we will subject it to time which is undefined in terms of its length. So we can apply limit where t would approach to infinity, and when we do, this formula of annuity becomes perpetuity. So this is the formula of perpetuity, which we can introduce to any certain amount to find out its perpetuity for the present value. So let us assume that that value which is occurring for an undefined period of time as benefit, which is received at the end of each year, it is represented with the help of capital A, and the simple formula to find out the present value of that perpetuity would be to divide the discount rate by the annual amount that is received. So the discount rate is positive. So now we can do this simple numerical in order to find out the answer. This is the annual amount which is received and the discount rate is 8%. We want to find out the present value of that amount that occurs perpetually. So the formula is applied here and we have substituted the values that we have found in this statement. Now we have the present value, which is this. So definitely it is much greater than the annual value, but it is also discounted over time because due to the time preference it needs to be discounted. So if this amount happens annually, and it happens at the end of each year for an undefined period of time, then the discount rate would be 8, and the discount rate is 8%. The final answer would be this. So simple solution guides us about the present value of the perpetuity, and this interpretation is quite helpful. Now we consider another situation where there is a growth or decline in the benefits or the costs, and that growth happens at a constant rate. So let's begin with this description that the project benefits or the costs, they grow at a constant rate. Right now we're considering the growth possibility, and that growth happens at a constant rate which is represented by G. And we consider that the benefits, they are represented by B. T shows time, which is in terms of years. And if the annual benefits, they grow after the first year, that is B1 at a constant rate, that is G, then the present value of such benefits would be this. This is the formula where we are trying to discount the initial benefits in this way, where we have this term which is the usual term in the discounting process. However, the growth effect has been introduced by subtracting the growth rate from this term. So this is the growth effect and this is the discounting effect. Here, if I is greater than G, then this formula holds because it will keep the discounting factor or effect valid. Otherwise, discounting effect will be reversed, which is against the intuition. That is, the time preference basically eats away the value of the resources over time, in our opinion. G is less than 0, in that case definitely there will not be an increase, rather there will be a decline, and that also is at a constant rate. Now we do this with the help of this numerical where the initial benefits are 100,000 per year dollars, and the growth rate is 2% per annum, and it happens for 4 years, and the discount rate is this much. So this is the value of the initial benefits, the growth rate, the discount rate, and 4 years are there. So the formula is this that we just saw, and simply by putting the values we can come to the result, and this is the substitution which you can perform easily. Here we have in the exponent 5. So it is basically the first year, that is where the benefits are B1, and 4 additional years mean that in addition to this year we have 4 additional years. So 1 plus 4 makes it 5. So the overall time period is 5. Now we can solve this and we will get this result, which shows that the present value is now greater, and that is due to the 2% annual increase for 4 years in the value of those initial benefits, where the discounting also takes place at 7% discount rate. Now the final example is related to the perpetuity, but this time there is growth or decline in the benefits that we are talking about. So it is a kind of amalgam of the last two exercises that we did. From the first exercise we can borrow the perpetuity, and from the second exercise we are borrowing the growth or the decline. Now merging these two would give us this case where the initial benefits are represented by B1 again, and the growth rate is G again, discount rate is also there, the present value can be found. So if you remember the first case where there was the value for perpetuity, but the benefits, they were not growing annually, the formula was simply B over I. But in this case, that growth rate which happened in the second example is now introduced because it is also present in this third example, and we are going to subtract it just like we did here. The same kind of treatment will happen in this case. Now this formula is ready, and again I should be greater than G for this formula to hold, otherwise this formula will make the denominator negative and it will give us a negative answer of the perpetuity, which is definitely not meaningful. And this tool can be applied in financial analysis, where it is known as the Gordon growth model, and it is applied on the dividends, because dividends, they can grow in a certain way, giving us annual returns with a growth or decline rate. So it's basically a kind of situation where the stock yields a constant flow of dividends that grow at a constant rate. And definitely we have seen this stipulation that I should be greater than G. And now we turn to the example which is here, that is $100,000, and it is growing at 2% per annum, and the discount rate is 7%. And definitely there is no time in this case because it is undefined. So these are the values that we substitute here, and the substitution after solution gives us this answer, that is this much. Now this is the present value, and we can interpret it that if this is the initial benefit and if it grows annually at 2% for an undefined period of time at discount rate 7%, it will become this much. So this is how we can calculate the present value for perpetuity, where the growth or decline happens at a constant rate. And this was the case where we were considering the annuity that is growing or declining at a constant rate, and it happens for a certain number of years but not for perpetuity. And this was the case of perpetuity, where there was no growth or decline rate in the value of the benefits. So this is how we deal with the perpetuities or the growth or decline rates in the annual amounts.